And welcome everybody to this webinar. We wanted to spend some time on this application that we built inside Neo4j. In essence, what we're presenting today started out as a dog food project within the company. At Neo4j, we kind of like to use our own technology for various purposes, and being a distributed company, and I'll elaborate more on this further during the webinar, and a fast-growing company, employees are kind of spread out across the globe, and we're all stuck in remote collaboration. Today, everybody's doing remote collaboration. We're obliged to, but for us, this is kind of standard. And so we started using our own technology to capture information from our instant messenger, to understand who's collaborating with who, how virtual teams are, what are really the virtual teams that exist, look at the cohesion of these teams, virtual teams that exist across departments and so on. See what skills are being talked about, which customers have a lot of activity, and so on and so on. There's you'll see during this webinar, there's a whole lot of ways to leverage instant messaging data inside the company. And with me, I brought Morgan and Niels, two of the guys who initially worked on this project as we started it out. They're part of the consulting team. We use these internal projects also to do study work. If you build a knowledge graph like the one we'll be showing today, there's quite a lot of technical elements that go way beyond just the Neo4j and graph modeling. There's some advanced data science here. There's some sentiment analysis. There's some elements regarding natural language processing, etc. And to make sure that everybody in the team is up to speed on all those skills, we also use the project for these. Project, a last piece of the history, project was initiated by Adam Cowley. I do want to mention him too, who's part of the team, who's now part of DevRel, and who'll be doing a blog post about this, about the same topic that should be published later today. So that's the introduction and the history of what we're speaking about, and then I'll dive into the agenda, give you a preview of what we're going to be talking about, and really get the webinar going. Okay. So first of all, I'm going to spend like 2 or 3 minutes introducing Neo4j. For those of you who might not be familiar with Neo4j, the graph database in the company, I'll do that quick introduction. And then I'll dive into the discussion around remote collaboration, some of the challenges you find. I will move from there on to knowledge graphs, how knowledge graphs can help you deal with some of those challenges. At which point, Niels will go in a little more detail and explain what the graph model inside this specific knowledge graph will look like. After that, we'll go into the demo. We'll show a thin front end. I must say, I think we got a pretty cool looking front end on top of what we build. But the real core of the application is the back end logic, is the database. After all, we are a database company. But we've got a cool looking front end, which I think illustrates really well the potential of this application. After the demo by Morgan and Niels, we'll also go a little more into technical details. As I said, there's a whole lot of technical aspects. Analyze moods, natural language processing, the actual graph model by itself. There's an element of data science, etc. Definitely worth talking about. And then to conclude, we'll talk a little bit about implementation aspects. How long does it take to build such a project? So that's the agenda. Without losing further time, let's kick off. So about Neo4j. Neo4j is today the industry largest dedicated investment in graphs. Neo4j has been around for more than 10 years. We can claim that we created the graph database category. We are by far the market leading graph database on the market. When we started out before 2010, there were no graph databases. We were the first one to create an open source graph database, long before any others were on the market, and that puts us in the position we are in today, being the market leader on the graph database. We're a rapid growing company, over 300 employees at the end of December 2019. We're way over that number by now, and pretty steep objectives for the end of this year when it comes to growth. We're pretty distributed, but we got a headquarter in Silicon Valley and offices in London, Munich, and Malmo. And although we started out, obviously, 10 years ago, working with smaller and more innovative companies, I would say where we do most of our business today is with Fortune 500 or Fortune 1000 companies, global enterprises. The global enterprise space has definitely discovered the power of graph databases, and we have an enormous traction in that market. A lot of attention there. So that's Neo4j. I want to spend 2 seconds specifically on Neo4j customer services and the professional services team. Company exists since 2010. Obviously, we're a product company. Software we sell is our key business. But as we moved into the enterprise space, as I just said, we started seeing the need for a separate consulting or professional services department. We started that department in 2017, just to make sure that as customers go into more complex graph implementations and embedding graphs into their wider IT environment, that customers get the right assistance. The professional services organization today has over 40 certified consultants and has been growing rapidly. It's one of the fastest growing departments within the company, and I think that simply aligns with the popularity of graphs in the enterprise space. Most people have over 5 years of experience in the graph space, which, knowing that this is a technologically a relatively new space, is quite a lot. Consultants have, on average, over 10 years of experience in the IT space. Background of most people is database, data modeling, analytics oriented. But as you will see also in this presentation, many Neo4j projects also have a custom front-end development. So the team also carries those skills. Team also has a dedicated, we also have a dedicated PMO group that helps keep our projects on track when it comes to just project management, best practices, etc. And we have a small dedicated solutions team that makes sure that we focus on making things as reusable as possible, and that includes some of the stuff we are presenting today. So that's about Neo4j. Let me move into the discussion on remote collaboration. So I'm kind of kicking an open door here. Everybody's talking about remote collaboration. It's thanks to COVID-19. It is the talk of the town. The news is full of how do I collaborate efficiently remote? How do I make my kids collaborate efficiently remote? One of the topics I struggle with these days is how do I get my kids on all these school platforms and get them connected to their teachers? I feel like I've turned into some tech support group for my own household here sometimes. But remote work has become the new normal for everybody. You can read that in the news. You can notice that on the stock exchange. Some of the companies that enable remote working have just have become so much more popular and have gained a lot of market space and have gotten a lot of attention. But for Neo4j, I would say that remote work is in our DNA. If you look at where we're based as a company, we're in over 20 countries today, and have been in over 20 countries for quite some time, and in more than 90 different locations. Because some of these countries, especially look at the U.S., the spread of people through the U.S. is pretty big, but the same in Europe. People are not typically located in one office. I would say the Malmo and the London office are probably the biggest ones. We have no more than 50 people in either of those offices, which gives a wide spread of the employees across the globe. Combine that with a rapid growth, and you have a situation where people need to get to know each other, need to be able to connect. You need to figure out who's the new guy that joined, and what is it that this guy knows. Okay, just to illustrate that remote work is in our DNA. Couple of screenshots, which are actually all of the last couple of days, I think. First screenshot just shows us collaborating on Zoom. That's our regular team meeting. Actually, you can see Niels on the left top there, and a couple of other guys from my team. On the right, you can see Emil, our CEO. I think you've for those who joined a little bit earlier in the waiting room, you must have seen a video of Emil, I think. Answering a remote Q&A session. So we'll use online tools to do a remote Q&A, allow everybody to send in questions to the CEO, which he answers live online. On the left bottom, you see an online graph modeling and whiteboarding tool which we developed internally. We use it with our customers to do whiteboarding around graph models, and have these interactive sessions where we agree what graph models are going to look like. And then last but not least, and that will get a lot of attention in this seminar, we use Slack. We use Slack very intensively. It's grown a lot in popularity the last years. And most of the companies extremely active on Slack. We've got a large Slack history that goes back several years in time. Stores quite a bit of knowledge of the company Slack. But going back to the challenges, fast-growing company, new people joining with new skills, new departments being added, new pieces of product being developed. We have questions all over the place. And we just extracted a couple of questions that are typically traveling across our Slack channels, and they fall in a couple of categories. If you look at the examples here, it's who has worked on this customer or on this type of use case, but also who has skills in, I don't know, Amazon, in Amazon, the Amazon cloud space. Who is our LDAP expert? Who has used Tableau? Who has worked on customer eBay? Who has worked on this or that? These questions fly over Slack, and this is a question we wanted to answer as a team. It's one thing to launch a question into the Slack space, and then people are pretty helpful in this company. Usually, you will get an answer and saying, "Hey, talk to this guy," or "I can help," etc. But sometimes your cry will just disappear in the dark because people are not continuously monitoring your questions. No, and to get around that issue, we really started thinking about, okay, how can we expose the information that is captured in Slack in a better way so that people can get to the skills that they need and get the help that they need. Okay. And I think that's in essence the questions that we started out when building this knowledge graph. So we wanted to talk about we wanted to resolve the problem of who is working where and on what, and how can I give other people access to that expertise. In addition, we also wanted to look at cohesions, like we've got people working together or interested in a specific topic. How can we see who are the people that are connected to that topic, whether that topic is a use case, whether that is a customer, whether that is a technical topic. How can we find those connections? Because that does not necessarily just follow out of the structure you find in Slack. It's kind of across all the information you have in that channel. And how can we consequently improve the efficiency of collaboration between people? Those were the things that we started out with. You'll see in the seminar or in this webinar that there's actually a lot more use cases and potential for what we've built, but this is where we started. So why did we look at a knowledge graph? And then let me zoom in for a second on the topic of knowledge graphs for those who are not familiar with the concept. We looked at building a knowledge graph because it could solve this specific problem. And a knowledge graphs have been around for some time. If you look at Gartner and some other industry analysts, they'll place it on the hype cycle, saying, "Oh, this is extremely hot right now." I'm not sure if I kind of agree with what Gartner says. Does matters little in this case. The reality is, we see customers and we see in the marketplace knowledge graphs have been around for actually quite some time. And reached a decent maturity. The knowledge graph that you probably all know the best is Google. Google is, in essence, a knowledge graph that stores information around how various internet pages are connected, and enriches that information so that you can do contextual search on that ensemble of internet pages and find the one that is most relevant. And that is what knowledge graphs are all about. And if you want to read up some more information, there is a whole use case section on our website that talks about how you can use knowledge graphs to get contextually rich search results. But knowing that, in essence, that is the definition of a knowledge graph, I hope that explains why we wanted to apply this concept to the problem that I just exposed. If you look at the concept of the knowledge graph, and I think data and graph databases in general, in a little more detail, the picture I'm showing here with regards to knowledge graphs, I find one that is extremely revealing. It doesn't matter what topic you are talking about, whether it's a Google knowledge graph or whether it's a knowledge graph about customer information or our Slack knowledge graph. As long as you take individual data points, you have very, very little information. When you start labeling and tagging those pieces of data, you start to have a first form of information. You could start do aggregation and counts of the various labels, and you could start having information. It looks a little bit more like what you do in analytics and data warehousing. If you start connecting then all the dots and find the relationships between the various nodes, as we'd call it in a graph, then you actually start to understand, then you start to gain some knowledge about how these various points are related. So, I mean, in the Google example I gave before, the page rank algorithm that explains how connected a page is completely changed the industry of searching the internet and search engines. So that relatedness and that connectedness is hugely important. Then, as a next step, you can start analyzing how 2 points within the graph are connected, or if they're connected. And that gives you insights you would otherwise not get, not from any other type of database or any other type of system. And beyond that point, and that is where you move from insight to actually real wisdom, is understanding which paths are most often traveled, which are the shortest paths, which are the most efficient paths, how paths are changing over time. That is really how a graph database works, and how it relates eventually to building an efficient or a good knowledge graph. So why use Neo4j for a knowledge graph? There's a couple of technical feature elements that are relevant. The first one I just spent time explaining: the ability to store and retrieve connections that provide you wide context. You can join from any piece of information to 15 joins out across your knowledge graph and find things that are related based on the type of relations you want to follow and the type of search you want to do. So it gives you a wide context, and it will do that with high performance, because a graph database just leverages relationships really well. But the graph database is also schema free. We cannot just store data as you do in an entity relationship database. It is schema free, and it allows for unstructured data, which obviously, if you're dealing with text and ontologies, etc., works really well. So you can bring in both structured and unstructured data and evolve the model over time. Neo4j also offers a wide range of free text search capabilities. Again, if you're dealing with textual data, super important. You can look online. There's various blog posts about how we deal with taxonomies, ontologies, semantics. Again, if you're doing context search, these things are important. And then last but not least, and we'll talk about this later, we've got a vast library of algorithms to actually mine the graph and find paths within the graph that are important. That is why Neo4j is good for knowledge graphs. Couple of use cases that are out there. I'm not going to talk too much about these, but if you want to read up on some of our well-known use cases in the knowledge graph area, look at the NASA video on our website. They've built a knowledge graph storing technical information from all missions since 50s or the 60s. And that knowledge allows them to, well, really do space missions faster and shorten the cycle to actually get, get to Mars or whatever the next place is we want to get to. Cisco Knowledge Graph is more around customer data and sales oriented. They've uploaded all their proposals and customer related presentations. They claim it saves them millions of hours in order to gain new customers and pull new proposals together. Look at the online videos. I won't talk about these ones too much. So let's get into the Slack knowledge graph after this introduction. As I said, it's a dog food project. We've got quite a couple of dog food projects in the company. We're doing analysis of our own Zendesk issue reporting. You got a screenshot at the top for that one. We use this for account mapping and understand who are the various people that are on Neo4j accounts and opportunities. We use it for our internal, our community website, and we use it for internal document search. And now we also use it for this Slack knowledge graph. At this point, I'll hand over to the guys who've actually done the work, and I'll let Niels pick up from here and explain you a little bit what data we loaded into the Slack knowledge graph and what the model looks like. So you get a bit of understanding how this really works. Niels?
Right. Okay, thank you, Jan. I'm going to get a bit more in depth into the data model and how we executed this project. See if I can switch slides. Right. So yeah, as Jan touched on before, this was really a two-phase project. The first phase was answering the what people are working on and which clients they work on, kind of a search capability on top of Slack, as well as Google Drive and Salesforce. So the magic of the knowledge graph in this case is also to combine different data sources and provide a unified view on these. And the second phase of the project was to build on top of this knowledge graph and investigate remote collaboration, right? So what I want to kind of go into depth here is that we can very easily reuse an existing knowledge graph and expand on it to answer new questions, right? Okay. So this is the data model that we used for our project. I'll quickly describe this. We tried to convert the data model of Slack into a graph representation. So what that looks like is you have your messages in the center, and messages contain references to links, attachments, threads, and they can also have emoji reactions, right? People write Slack messages and people are part of channels. And what we additionally did is we defined a list of skills and we defined a list of clients that we have internally as an aggregation of a layer on top of this graph. So to give you a bit of a more visual representation of what this looks like, we take a message on Slack. We have a message here with an attachment on it, and we convert that into a graph format. Another message with a reply here. We see that the reply becomes a separate node in our graph, as well as the emoji reactions, the sunglasses and the thumbs up here. So by mapping all these little messages to a graph, we'll get this giant intertwined knowledge graph of our entire Slack. And that is by itself is already super interesting because it allows you to contextually search along this graph. So that was enough for our first use case. And then adding the aspect of remote collaboration, we wanted to extend this graph with team information. So we took some data from our internal database and we extended this into the graph. So we changed the model to incorporate a hierarchy of teams. So we have a little cipher statement here that find the managers for the separate teams. And our new model would then have another node here at the bottom that has a team for every user. And that's one of the things that's also quite nice about Neo4j is that we don't have a static model. It's super easy to extend this and add this to your knowledge graph. And with this team information, we can answer new questions like how do certain teams collaborate and how often do people between teams talk to each other. So that's a bit how we evolved from an initial graph that just answered questions about skills to an extended graph that can be used to analyze how teams work together. Right, I'll hand back over to Jan to introduce the demo part.
Okay, before we get started, do want to highlight that the demo you'll see is anonymized. You won't see real Neo4j employees, customers, and you'll only see partial data. Actually, I'm not sure if you guys will notice, if you look careful at this, you'll see that the data is sometimes incomplete. There are gaps. That's deliberate. We've tried to anonymize the data as much as possible using some of the techniques that Neo4j allows you to, because there are certain restrictions on what you can do with private data. And that applies both to the development work as well as to what we rolled out. So during development time, we've worked with a test server with anonymized partial data. In real life, working on this with the end users, and then we've rolled out to a limited set of end users initially to start with, because again, we want to be careful about how we use this. We only exposed initially public channel data, so anything that's on public Slack channels. For those who are familiar with Slack, Slack has the concept of both private Slack channels and public ones. We only do the public one, so data that anybody could see anyway. We only expose aggregate data via the application. There is no way that people can actually get to the detailed Slack conversation. Okay, so we'll explain some of the internals, but you will not see that. That's anonymized because obviously there are some rules you need to respect in real life, and I'll talk more about that when we get to the implementation side. So I just wanted to add that before we dive into the demo. We'll get into the demo. The first part, Morgan will introduce. He will show you the application we built, and that allows you to find skills within the company, see how those skills relate to customers, and kind of assess the overall situation of a customer, which documents are being used, who's working on who's on the virtual customer team, and so on. That's the first part, and then Morgan will hand off to Niels, who will show a couple of examples of more one-shot analytical queries, which are more in the area of mood shifts and sentiment analysis. Okay, Morgan, I'll hand off to you.
All right, so I will just start by sharing my screen. Hopefully you can all see that now. So this is the application we built on top of our Neo4j databases. So if you look at this home dashboard, it basically gives you a company overview of how your company is going. You can see on the left side the top skills based on the number of time skill has been mentioned. And you can see the skill liking, which is calculated the same way we calculate the top skills. So the insight of these skills, liking and top skills in your company is helpful, because if you have some activity within a customer, let's say around Cassandra, for example, you can see that we are lacking competencies in Cassandra, for example. So you might want to have or give trainings or to have some materials around Cassandra for your employee. On the active customer, well, as I just said, it basically gives you insight of which customer are having activities and which one you want to probably focus within the current month. And on the active user, it just gives insight on how your users and how your employees are talking to each other, how they are working remotely in this context. If we just scroll down a bit, you can see some trends. So on this, you can see the trends on your company, how your company is going on the remote context, how they are using your instant messaging tool. So in this case, it's Slack. And you can see some trends around the skills. So you can see here that as the backup and browser skills are going down by 50 and 40%, or which is for some of the ones that don't know already, is our cloud provider. It's going up to 25%. So once we figure out which skills we are lacking and which customers are have some activities, we might want, let's say, to load some JSON within the Cassandra database, but we don't really know how to do it because we don't have the competencies. Well, with this skill dashboard, I can just look for the skill Cassandra, right? And then I just want to load a JSON. I just said, right? So I can just look for JSON. And what it does, it will basically look for every person in our Neo4j database that have both Cassandra and JSON skills. And if you have like an emergency questions, you really want an answer right now, straight away, you can just filter on your current time zone, right? And what it does, it will basically give you the list of people that have the skill set you are looking for. A really nice feature is that we integrated with the community website as well. So if you are looking for skill set, you will also find related articles that you can click and look for. So as I just say, I wanted to load some JSON on Cassandra. This article might be useful. So That said, right now, if let's say I have a question on this JSON loading in Cassandra, I want to contact Michael, but I want to have more insight on what does he know around that. I can just click on Michael, and it will go to the user dashboard where I can see more metrics around Michael. What skill does he have? What skill does he have that other have in the company, and some metrics on how the skills are calculated. So every skills you can see have a score. The score will be explained by Nils later on. It's a skill algorithm that we use to calculate it. If we go to the customer dashboard now, so if first I go back to the home dashboard, we saw that there are some activities within a bank and company, right? So if I go to client and I want to know more about this company, I can just look for the customer and you will have this dashboard, right? So what we can see here on this customer first is the activity on the Slack channel, which you can see is 2 picks, right? And what it gives as an insight, or that in March, there was some talking around training. And if you look at the trends, it was more specifically on link use training. And as we delivered in March, the need for training on link use went down, right? And you can see the last peak here that is actually increasing since the 20th of March. You can see the trend for the support that is increasing as well. So you can match what are the activities and what, based on the skills sets. You can also see the team members that worked for this customer. So it's not a team as within who report to the same manager, but really the actually remote team. So everyone that were involved in this customer, right? So it's really convenient. If you have a question, you just join the project and you have a question, you want to know more about something, you can reach out to those guys with some integration with Slack as well. And as I said earlier, we have some Google Drive integration as well. So you can quickly go into the Google Drive folder for this customer and find some helpful documentation. Now, talking about documentation, that's the last dashboard that we built. This gives you some insight of how documents and especially documents within the customer are used within Slack, and how you are sharing knowledge, especially in this remote context. So the first trend here shows you how documents are shared per weeks. And this is really showing actually that we are getting higher and higher on sharing documents. It also gives you insight of where you are lacking knowledge for a specific customer with this table here. You can see clients that don't have a Google Drive folder, or clients that have a Drive folder but without any documents, which is really helpful to know which customer you don't have more insights. On the document type, you can see how document type are used and which document are shared within your channels. Now, this one is kind of important as well, especially on the skill knowledge, right? You might want to know which skills have the more documents, especially on best practice, and which one do not have any documents, or the least document, right? So that way you can say, okay, we don't have much document on how to export maybe and CSV. So maybe we want to write a best practice around it, right? If we have some free time. And also if you're looking for a document or on Go, for example, or on a database or Bloom, you know that we already have few files on that. The larger duplicate files is to show you how you're using your Slack plan, basically. And the more shared document is a way of saying what skills or what documents related to which skills are important because they are shared the most time, basically. And that's it for the demo. Now I will just hand over to Jan, to Niels, sorry.
Right. So besides this dashboard, we also did some one-shot analytical queries on our knowledge graph. And these provided some insight on some more detailed questions. So something that we haven't touched on before is that we used sentiment analysis for both the messages and the emojis that are used in the Slack conversations. And what's nice about that is that you can aggregate these sentiment values over time. So a nice example here, we're looking at all the employees that are based in London, and we're looking at how the sentiment values in their conversations evolved over time. And what's interesting to do here is once you have this kind of graph, is you can identify the peaks and the dips, and we can actually link them to certain activities in the company. So the first one here, all the way on the left, is when a beloved teammate left, there was a significant dip in the happiness of the employees. What the biggest peak all the way at the end is when it was, I think, a couple of days before Christmas, when everyone was wishing each other a Merry Christmas. So that resulted in a really high sentiment value. In the middle here, you have a bit of a weird dip relating to the launch of our new product, Aura, which was due to that some emojis can be used both in a sad setting and in a happy setting. So these are the laugh cry emojis, which are sometimes used to represent crying, but also to represent happiness. So that's a bit of a weird artifact in our data here. But nevertheless, it's very interesting to see that certain events can impact the sentiment in a company. Just go to the next one. So what's also interesting, aside from geographical aggregation, you can look at a certain team. And what was interesting to see here is that once our company started making announcements about coronavirus and closing the offices, we saw also a significant dip in the members of the European team. So in situations like this may provide some insight as well into what is causing changes in people's moods and which teams are most affected by these kind of measures. And that's exactly what we're doing here. It's going to be a bit small, but this is an ordered list of all the teams that work in Europe and how much the average sentiment of their messages has changed over time. So at the top here, we see that the customer success team has, on average, became the more negative after the coronavirus announcements, and the developer relations team has become a lot more positive. So this is an interesting way to see how and where measures like this affect the teams. What's interesting to see as well is, I think Jan touched upon this before, is that communities within a company, teams within a company are not always the explicit teams that we're part of, but people that communicate frequently are implicit teams. These are teams that we don't define, but they do exist because they're working together on different things. So what we use is the Neo4j Data Science library to do a community detection algorithm based on people that frequently reply to each other, and we group them in different teams. And that's something that you can see here. This may provide really interesting information about which people collaborate across teams very often and which people do not have this particular trait. And then the next level of analysis that we can do is we can look at cross-team collaboration. So we look at all the people in a given team, and we see how often different teams within a company collaborate. So what you see here is you can see thicker relationships between the teams here at the bottom and the teams at the top. So that would indicate that these teams have a stronger collaboration measure than the other teams, to kind of visualize how your company internally works together. So these are all very, very interesting things that you can discover with this kind of knowledge graph. Right, I'm going to go ahead back over to Jan to give a quick summary of everything that we've done so far.
Okay, so I hope the demo has shown you some of the things that we talked about at the beginning, how you can find the right skills within a specific context, combinations of skills, a skill without other skills, etc. How that enables people then to connect to peers that are in the same time zone, and that can help them achieve whatever their goals are that day. Understand what are the virtual teams. I think the demo has also shown a little bit how we can actually collect more info that could be relevant for a wider customer 360 initiative, or a knowledge management initiative. I'll talk again about it in a second. But if you look at the screen that Morgan showed, where we show which are the documents that are used most in the context of a specific customer, or what are the skills that are relevant to a specific customer, those are elements that are very useful to our support teams, for instance. We've shown examples of how you can measure activity across specific customers or in teams, how you can measure the mood changes, and how we find virtual teams or implicit communities. I hope that all came across. I see, make a small parenthesis, I see a lot of questions on the right. We're never going to get through all of the questions on the webinar. We'll try to find a way to answer some of these later on. Okay, beyond remote work, if you've been listening, there's a lot of other use cases possible here. For sake of time, because I see we want to go through some of the technical stuff still, and we only have 15 minutes left. I'm not going to elaborate on this too much, but there's a whole lot of other use cases that the same graph or very similar graph could be used for. Look on the use cases on our website. There is plenty of inspiration there, but if you've understood the model and take inspiration from what we've shown here, I'm sure you guys can come up with a lot of other use cases. So let's take another 5 or so minutes to do a bit of a technical deep dive, and then leave 5 minutes to close out. Morgan Niels, I'm gonna hand back over to you. So Morgan's going to talk a little bit about architecture using Kettle and the front end we built. And Niels going to talk a little bit about the scoring and sentiment analysis, as well as some of the graph data science that we applied.
On the architecture side, you can see on the left side various data sources that we used. So again, we use Slack here because we are using Slack internally, but you can use pretty much everything you want as long as you can export the data or reach it through REST API. We use Google Drive, as you saw in the demo, because we wanted to integrate and see where the knowledge is within your Google Drive. We use Salesforce to integrate with our customers, so we can link actually channels in Slack, Google Drive folders, and with our customers in Salesforce. And we use GitHub for looking for skills in our Git repository, basically. So once you define all the data sources, what you want to do is load them into Neo4j. And how we did that on this demo is by using, as Jan mentioned, Kettle and Python. So Kettle is an ETL tool. There are various of other tools. We choose this one, and I will go in further detail just right after this architecture slide, why we choose that. We use Python for the sentimental analysis, and especially using NLP, and to load some data as well. And I will explain that later. On the Neo4j cluster, we are using a causal cluster hosted in Neo4j Aura. So for the one who don't know what Aura is, it's actually our cloud provider. So you can just click and quickly have some databases up and running in Aura, which is going to be on the cloud, and you don't have to manage it. You can just create a causal cluster and use it straight away. So once we got all that and we get the data on the Neo4j cluster, we'll build a fairly light front end, because as we mentioned earlier, we are a database company. We wanted the focus to be more on the database and on loading and analyzing the data. So in this one, we used Vue.js, and it was an application built in a Neo4j application. So we can integrate with Neo4j Bloom. So that's it for the architecture. So now I will just go through every details of what tools we used. So ETL using Kettle. We choose Kettle because it gives a lot of flexibility actually. So the first thing is in Kettle you have Neo4j connectors, right? And what it does, it's a workflow orchestration. So it gives you the ability to say, okay, I just want to start from here. I have my data here, and I want to extract them, manipulate it. So I want to aggregate, manipulate the data, transform it, do some filtering, and that's where we did the anonymization actually, and then load it into Neo4j. But it's not the only thing. Actually, with Kettle, you are able to parse JSON, you are able to embed Python, and that's where we can actually say, okay, you have some Python scripts which are running sentimental analysis, but we want that to be part of the workflow, so you can just take your Python script and put them in Kettle. Obviously, we did some logging and error handling, some restartability as well. So you can restart from any point where it previously failed. And we'll just explain that on the next slide. So how does our Kettle workflow looks like? So there are 4 parts actually. The first part is to create a batch process. The batch process is a way of saying, I'm starting an ETL process. I'm starting to load some data, and that would be a process where I want to list all the files that are available, and I want to load them, right? And once a batch process is done, we can just close it, and as long as you want to update all the data, you can just create a next iteration. So you can see on the screen, on the slide, you have the first batch, which is a green node in Neo4j. You have a next iteration, and you have another batch. And it can go that way all along as you want, as long as you load data, right? So once you created a batch, what do we need to do is to basically list all the input files that you want to load, plus the one that failed previously, if any, right? So if you have a previous run and for some reason you were not able to load the files, we will flag them as failed with a Neo4j label, right? So that way we can keep track and we can have the restartability of to restart wherever it failed before. Once you got your batch and all the files attached to that batch, you can just loop through every files and load them into your databases. On the front-end side, so as I said, we used Vue.js. Why? Because it's modular and it has a flexible development environment. As Jan mentioned earlier, this was a fair light front-end. We were just more focused on the backend. Obviously, if you want to move forward into production, we would highly suggest to use GrandStack because that's our recommendation and a solution that is much more flexible and give you more features out of it. And you can see on the slide as well, we use Vue.js because we wanted to separate the design from the code. So you can see there you have the front-end code, and then you have the backend, which is the Cypher queries. All right, I will just over to Niels now on the sentimental analysis.
Running low on time, but I'll quickly elaborate on how we did the sentiment analysis on the text as well as the emojis. For sentiment analysis in text, we used a Python library called TextBlob that will return a value between -1 and 1, depending on the, I would call it sentiment, the happiness of a given sentence. The emoji sentiment is based on a research paper that we found where they analyzed a large number of documents online and tried to correlate the emoji being used with the sentiment value. So what you can see here in this visualization is that the heart all the way on the right over there will have a very high sentiment score as well as a very low neutrality score. Neutrality is here how objective an emoji is. We didn't use this in our current implementation, but this is something that paper investigated as well. Very quickly on the data science options that we used the recently released Neo4j Graph Data Science library to do a community detection. There are a lot more options here to get more in depth, but we just wanted to show that these kind of things are very possible with this library. So if you have some time to check this out, this is really, really interesting. Right, I think I'll hand over to Jan, and we should be done pretty soon.
Thanks, Niels. So I'll talk a second about implementation, and I'll really keep that one short. So if I look at the internal project we initially did, I think getting a V1 out of what we built took us roughly 4 to 5 weeks. If we structure this in other approaches with customers where we've built knowledge graphs and done similar things, obviously there's more of requirements analysis to be done, and there's a little more of discussion to be had. But typically we're talking implementation time 2 to 3 months. The way we do it is shortly outlined here. I'm not going to go dig too much into project management methodology and how we do this. Key element is our approach is very agile and very data driven. You have to validate early and fast whether whatever you're presenting is correct. I think those elements are key. But the most important message is that, and I see that on the Slack, I see a lot of people saying there's a lot of complexity here. But Neo4j plus a couple of other techniques that we've used really allow you to do this type of knowledge graph in a very short time frame. Will it be perfect after 4 or 5 weeks? No, I think if you start building a knowledge graph like this, it is something that you can keep on tweaking forever and enriching. What are key elements during implementation is first of all getting to the data. If you don't have the data, that is a challenge. And I see there are some questions about data extraction from various messenger tools. I'll see whether we can get to answering those. Once you have the data, you have to consider anonymization. You can anonymize, you can sample, but you have to protect the data. There are rules around GDPR, privacy, HR policies, which you need to respect during development time and after rollout. And eventually, if you want to deliver fast, you need to narrow down the objective. There's so many things you can do with this type of knowledge graph. You've seen us at least answer 5 or 6 different questions with the graph that we initially built, and in the first iteration we built in like 5 weeks or so. Those are elements you absolutely need to be careful about. If you get these right, you can do this really fast. The last element is more about how are you going to use this, roll this out, embed this into your organization. We deliberately did not spend a whole lot of time on that because that's going to be different for every customer and the use cases that you prioritize. So I'm not going to go too much further in these details. Anybody interested in implementing something like this, please reach out to us. We're happy to talk you more through how that would work. And that brings us to the end of this. Seminar. Please reach out. Any technical questions you have, questions we've not answered yet. If you want assistance with implementation, whether that's in a workshop or us assisting you to do this, just let us know. Contact details are on the screen. We'd love to talk to you guys.